A salvage vessel locates a sunken ship 165-meter below the surface of the water, and the angle of depression to one end of the ship is 55 and to the other end of the ship is 49. So you have to find the length of the ship to the nearest meter. Okay. So this is how the ship is. This is one end. This is other end. And the sunken ship is the sunken ship, and this is the salvage vessel. Let's call it SV. Now, SVC is one end of the ship and the other end of the ship like this. And the angle of depressions are given to both in both the cases. This is smaller angle definitely, so this is 49 degrees. And this is the bigger angle, which is 55 degrees. And this is the height. What we need to find is the length of the ship. It means that we need to get this particular length. Let's call it x. This distance is unknown to us. Let's call it y. And this distance is also unknown to us. Let's call it, okay, not this distance is known to us actually, because it is located 165 meter below the surface of the water. This is 165. Okay, let's mark the vertices. It's A is going to help us eventually. This is A, this is B, this is C, and this is D. Now, also one more thing which I want to locate on this curve is this angle and this angle. So both these angles can be easily found, because if this is 49 and this is also 49, because they are alternate angles. So this is 49 degrees, and if this is 55, then this is also 55, which is also because of alternate angles. I'm going to say that this is because of they are alternate angles. So since we got the value of angle, since we got the value of everything what we need over here, now we are going to start our calculation. First, we are working on triangle ABC. In triangle ABC, which is over here, I'm interested. In fact, let's try to do the same thing in triangle ABD rather. ABD is the bigger triangle, and what do we have to find? We need to find x. So I think in this triangle, using tan of 49 will be a good choice, because tan of 49 will relate the opposite and adjacent, and opposite is known to us, and the adjacent has x, which we have to find. But remember that adjacent is BD, which is x plus y. So we have x plus y over here. If we cross multiply, then x plus y will be 165 over tan of 49. And if we subtract y both sides, because we need to find x, that will be 165 over tan of 49 minus y. Now, y is something which is not known to us, and that's where we call this equation 1, and other triangle comes in, which is ABC. Now, in triangle ABC, again, I'm going to use tan, and this time opposite is known to us already, and the adjacent is only y. So we can easily get the value of y by cross multiplication. So the value of y will be 165 over tan of 55 degrees. So the value of y from here comes out as, let me just, in fact, let's keep it like this. Let's keep it like this. So we got the value of y as well. So all we have to do is substitute y from 2 in equation 1. So I'm going to say that from first and second, I'm going to write that x is equal to 165 over tan of 49 degrees minus y, which is 165 over tan of 55 degrees. So we can get the value of x from here, which is the length of the ship. We have to round to the nearest meter as written over here. So to the nearest meter, that's going to be equal to, let me just grab my calculator. That is coming as 165 over tan of 49. Make sure your calculator is in radian mode, degree mode, of course, minus 165 over tan of 55, which is coming as 27.89. So to the nearest meter, that is coming as 28 meters. The unit is meters. I just want to make sure of that. So let me just go back up. And yes, 165 is in meters, so definitely x is also in meters. Thank you.